I'm Aakar from University of Toronto, and I did this work in collaboration with Ravin Balakrishnan. So, typing on smartwatches, why is it hard? Well, if we have the entire QWERTY keyboard on a smartwatch, the keys are just too small for our fingers, right? So what is DualKey and how does it solve this problem? DualKey is a text entry technique for touchscreens that uses finger identification. Now you can see that the keyboard layout here is slightly different. It is still QWERTY, but there are two letters on each key. So if you see the first key, it's QW, right? And let's assume that the user is wearing the watch on the left hand, and they're typing with the right hand. So in DualKey, they type using their index and the middle fingers both. So they would type something like this, right? And the idea is very simple. If the key is tapped using the index finger, then the letter on the left of the key is typed. And if the key is typed using the middle finger, then the letter on the right of the key is typed. So let's look at the key TY here. And if the user presses the key TY with the index finger, then T will be typed. And if he presses the key with the middle finger, then Y will be typed, right? So it's simple. Now, this enables us to double the size of the keys while keeping the QWERTY layout intact and without introducing any new gestures for typing. The question, though, is why do we actually need DualKey when we have so many other existing typing techniques? And there are many impressive typing techniques that have been proposed for smartwatches. The problem, though, is that almost all of them share two drawbacks that makes them somewhat inefficient. So let's talk about those drawbacks. We single out 3 keyboards from the literature that have been shown to perform well. And so the first drawback that they share is that they use a 2-step process for text entry. So in the first step, the user locates the key on the keyboard while zooming in or swiping or doing something, and then only on the second step can they actually perform the entry of the character. And this is called gestures per character, right? So if you look at this table, then all of these techniques have gestures per character values which are more than 1. And for our smartphone keyboards, it's simply 1, right? You just tap a key and you're done. It's fluid, it's fast. And here, all of them are more than 1. Now, the second drawback is that most of these keyboards do not just rely on finger taps, but also use finger swipes for entering characters. And the problem is that on our regular smartphone keyboards, swiping or sliding gestures are used for additional functions, like shape writing, like the thing that Ziajun was talking about earlier, right? And when we have swiping or sliding gestures that are part of separate character entry of a keyboard, then we cannot use them for these additional augmentations like shape writing or any other things people come up with. And anybody who has used an Android soft keyboard or the Swipe app or the SwiFTKey app knows how useful these are. So when we look at these keyboards, we see that 2 of them use swipe, and the third one, which does not use swipe, has a high gestures per character value. When you look at DualKey, then it has a gestures per character value of 1, which basically means that it enables text entry using a single tap without any swiping gestures. But the question is DualKey really efficient when it comes to typing? Because the user still has to switch their fingers while they're typing, right? And so we built a prototype and we conducted a study. So for the prototype, to identify fingers reliably, we use an optical sensor mounted on the index finger, which tells the watch if the index finger tapped the screen or not. Now, of course, this setup cannot be used in the real world. But there are efforts, both commercial and academic, to practically realize finger identification on touchscreens. And so our aim in this work was to investigate the interaction technique and not the specific hardware. So the study, we designed the study emulating the prior smartwatch typing studies so that we can do cross comparisons later. We had 10 participants who did 25 quizzes each day for 10 days. And this long-term 10-day study allows us to see how quickly the users get good at typing with DualKey and how good can they actually get. Okay, the results. So this shows the mean typing speed in words per minute over the 10-day period. It starts with, as you can see, with 11 words per minute on the first day, and then it climbs to 19 words per minute by the 10th day. And in fact, we ran a couple of users for 5 additional days, and they achieved speeds of 25 words per minute by the 15th day. So the performance improvements don't just stop even after 10 days. And 25 words per minute for a screen this small is not bad, right? So how does it compare to the existing techniques? Okay, so we again go back to the 4 techniques, to the 3 techniques we had earlier, zoom board, split board, and swipe board. And we use 4 metrics: the novice and long-term speeds and error rates. Now, of course, even though our study design emulated earlier studies, we cannot statistically compare these techniques. But we can still infer if the performance differences are large enough or are comparable to each other. And the first metric that we use is the novice speed in words per minute. That was achieved after 10 minutes of practice. And DualKey performed better than 2 of them, but not split board. And that is because finger switching is a bit unintuitive at first. So we then look at long-term words per minute. And here we see that DualKey is better or comparable than all the techniques that have had long-term investigations. Split board did not have a long-term investigation. And in its study, it did not report a significant learning effect over blocks. And given the simplicity of the technique, that suggests that there won't be a significant learning effect over time for split board, and it has already reached its peak performance. But of course, like, we are speculating, and we need an exhaustive long-term study to find out what's what for split board. Okay, so now let's look at the error rates. We're talking about the total error rate here, which includes both corrected and uncorrected errors. And this is where we see DualKey being a lot better. It's 6.3% compared to the others. And when we look at long-term error rates, again, DualKey's long-term error rates are far lower. So we see that the error rates are low and the speeds are relatively good. But and DualKey seems like a promising technique. But still, finger switching is affecting the performance. And so we asked, is there a way we can address that issue? We can address participants who told us that, I still feel that finger switching is not, I have to switch fingers a lot. And so we looked closely into the data for the time taken for switching between fingers. And here the y-axis is the time taken between 2 characters for different combinations of fingers. So I means that an index finger tap was followed by another index finger tap. Similarly, IM means that an index finger tap was followed by a middle finger tap. And similarly, MI and MM. So the lower the mean time between characters for a finger combination, the better that combination is for speed. Now we see that the lowest time taken was by II, which is obvious because it's index finger followed by index finger. Then we have MI, which is middle followed by index, and then IM, and then MM. So both the cases where the user types the second character with the middle finger, IM and MM, take up more time. And this is because typing with the middle finger is not as fluid or intuitive for us. And these differences are statistically significant. So the next question we asked was, can we use this data to design a more optimized keyboard? And that is what we did. We performed an optimization of the assignment of fingers to letters such that the average time between characters is minimum. And this is what we got after the optimization. I won't go into the details of how we did that. You can read the paper. If you notice, you can see that most of the high-frequency letters are assigned to the index finger. Now, the problem here is that we won't have a QWERTY layout anymore, which is important, as we saw in the earlier presentation as well. And therefore, we perform a second step of optimization. So in this step, for the optimized assignment of fingers to letters that we got in step 1, we optimize the keyboard layout to be as close to QWERTY as possible. And this is the final optimized layout. We call it the sweqty layout. And if we compare this with QWERTY, we see that it's not that different, but still, I mean, users would find it a bit weird. And again, we wanted to find out if this theoretical improvement that we have optimized for is actually reflected in actual use. And so we conducted another 10-day study for sweqty. And here are the results. As we see, the speed of sweqty is consistently on top of QWERTY. Now, this was not statistically significant over 10 days. But it is still interesting because even on day one, when the users had zero familiarity with the sweqty layout, the performance is still comparable or possibly better than QWERTY. So the benefit of optimizing finger switching outweighs a familiar QWERTY layout right from the start, right from day one. More interesting here is the error rate, which we see that while it starts out very similar to QWERTY, it drops drastically and in fact is close to half the QWERTY rate by the end. And this is a big improvement, and this is statistically significant. Okay, so let's go back to the table and see how sweqty compares. Now, we see that the novice speed has increased and now is more comparable to the splitboard speed. And when we look at the error rates, they look even better now. Okay, so we have this technique for text entry on smartwatches, and we see that it is comparable or better than existing techniques on novice and long-term speed and accuracy. Plus, it involves single finger tap and does not use swipe. But there are open questions and future work to be done. Firstly, if we include language dictionary, we can incorporate autocorrection into the keyboard, which might prove to be even more useful for our technique. Then you can also augment the keyboard using shape writing gestures on the layout. Then there is finger identification. As I mentioned, there are ongoing commercial efforts by Apple and others for integrating fingerprint readers into touchscreens. So it is probably only a matter of time before we have touchscreens distinguishing fingers. But we have other methods we can do that as well, but we don't have to wait for touchscreens to have finger identification. For instance, smart rings are getting more and more traction, and we can imagine scenarios where users are wearing their smart rings on one of the fingers to distinguish that finger. So based on our observations, there are some takeaways if one is designing finger identification interactions, right? So firstly, reducing finger switching even at the cost of impacting familiarity of an interface is an exploration that is worth undertaking. And as we see in our particular case, right from day one, we saw that even when we deviated from the QWERTY layout, the performance was better. Secondly, the middle finger taps expectedly take longer and should be assigned low-frequency keys or low-frequency operations. And finally, such interactions will be prone to occasional mistakes from the users because they use the wrong finger. And so there should be a way to quickly undo or swap that interaction. So for example, in DualKey, we had the swap key, which you can see at the bottom, which switched the letter that was typed. And so if the user used the wrong finger and they typed T instead of Y, they can quickly press this key to swap the letter to Y. And you notice that the users used this a lot initially when they were making mistakes. Okay, so finger identification is something that is potentially on the horizon, and we need to think about how we design interactions that draw on this capability. And we think DualKey is a step in that direction. Thank you.
Microsoft Research. I see that you have very interesting quantitative results, but what about qualitative? To me, it seems like if you have 14 keys for which you actually have to distinguish whether to use the first or second finger, the cognitive load would be pretty high. So did you ask people how natural it seemed? What was the perceived ease of use? I mean, what are the qualitative findings?
Sure. Yeah, I should have included some codes. You're right. Even at first, when we were exploring this, we thought that users would find it really difficult. And on day one, that was the case. So I won't say that it wasn't. But by day 3, a lot of users were saying that they did not, for most of the words, they were not consciously thinking about switching their finger. It just came to them. So I think it became part of their muscle learning. And that's the feedback that we got. So, I mean, I don't think that the mental load after day 1 or 2 should be that high. And the second thing that I want to say is, let's assume a future where finger identification is in touchscreens, integrated, and users are routinely using their fingers interchangeably. Maybe in those scenarios, this might not be a problem on day 1 even. So, yeah.
Brad Myers from Carnegie Mellon. I just had a quick question. In your experiment, did you actually have a way to differentiate their fingers?
Yeah. That's the optical sensor that we had. And that worked with, so we did an accuracy experiment earlier, which had 99% accuracy. So we were able to identify the fingers 99% of the time.
Like by watching from below, or?
Oh, it was an optical sensor on the finger. So whenever the finger touched the watch, if it was the index finger, then the watch knew that was the index finger that. Yeah.
Hi, Eddie Isaac from Bloomberg. Question about the fingers that you chose. Index finger seems very natural. I'm curious why you use the middle finger as opposed to maybe the thumb, or some other finger that we might be using for mobile devices.
Yeah, and so at first it was just, that this seems more natural than, I don't know, this, right? But then we looked at the literature, and there was a study, I think last year, or maybe last year, which investigated the dexterity and the individuation of different fingers on the hand. And it found out that for the index and the middle fingers, our dexterity is far higher than for, let's say, the ring finger. And obviously, thumb, when you look at the thumb, it's kind of weird to do that, right, on the smartwatch. Maybe for a smartphone, you can have like 2 thumbs and type using that, and the thumbs are identified. That will solve this fat finger problem on the smartphones as well.
And a quick follow-up question. I'm wondering if you have any idea of how many of your users were touch typists, and if that had any influence on having to figure out which finger to use, or just because it's a mobile device, maybe it's clear they're using an index finger, but if they have a predefined finger that they want to use for a particular character, if that influenced them.
Yeah, we did not control for touch typists. We just asked them if they were regular smartphone users, and they were. None of them had used a smartwatch before, and yeah.
I'm Sanjay from Samsung. I've seen few keyboard layouts where there are multiple keys on the same key.
Yeah.
So I was just wondering whether you have compared your results with such a keyboard where you can use Shift to move to a different key, same key, or there are keyboard layouts where you can long press on a key to generate the other.
Yeah. So there are lots. So I mean, if you overload a button with 2 letters, there are a lot of ways that you can disambiguate that. Like, for example, as you mentioned, long press or shift, or something like T9, or pressure. I don't know. But the point is that the interaction, what we were aiming for is simple taps. We did not want any long presses or any shifts or any multiple taps on the same key. Although if you're looking at gestures, then there is something called slide board, where you slide your finger on a key, left or right, to know, to identify which key you're typing. But that was already compared with the existing techniques, split board and swipe board, and it was not good at performing. So that's why we did not compare it. Yeah?
Okay, that's the question.
Hi, Anna from Art University. You're saying that, or you're supposing that you found that changing a finger is slower than typing with one finger. This is very contradictory to what we usually think about how we operate keyboards, where changing the finger is usually faster because you have the longer toggle time with one finger.
Yeah.
So I'm wondering if it may be the case that there are other factors that just make it seem like this is the case. For example, that you have space problems if you have to tap the same key twice with different fingers. Of course, this is then maybe slower, but maybe it just seems like that, and there are the other factors.
Yeah, so it's not, yeah, so you're right. I mean, there could be other factors as well. But the point is that when you have two letters on the same key, users have to cognitively think about which finger to press for that button, for that key, right? And that is the thing that takes time. So it's not the operation, because the operation would obviously be faster because the middle finger is ready to be tapped and you just need to bring it down instead of bringing the index finger up and back down again, right? So you're right that physically it should take less time, but cognitively it takes more time.
Maybe one thing you could take into account for optimizing your keyboard is that you put those frequent letter pairs that would be would need a switch of fingers, that you put them further apart.
Yeah.
Maybe that's easier than to prepare and to hit the display.
Yeah, there are multiple ways we could optimize the layout of the keyboard, and we chose the way that like our data showed us, but it would be good to explore the way you're suggesting. Yeah, definitely. Yeah.
Thank you very much.